Alright, area of a sector. So the formula you need to know. A is the half r squared theta. Alright, that will give you the area of a sector. So a sector is a portion of the circle that's bounded by two radii and the arc formed at the end of those two radii. The thing of this is you're cutting a slice of pie, a slice of cake, okay, the top here is a sector. Alright, so the area of that sector is that. Now, you need to remember, these calculations, your angular measure and also your calculator need to be in degrees. In radians. Okay, they cannot be in degrees. Unless you are converting your radian to degrees. And then using the exact results anyway, etc, etc. But it won't always work like that. Alright, so you need to make sure that you are getting the right answer. Alright, proof. 2.3. So I'm going to prove this using the similarity concept. So I've got a circle, alright, two radii that forms an angle theta at the centre. Okay, we'll call the radius r. Okay, so we're going to look at some similarity and get this working. Okay, so the area of sector over the area of circle. Alright, we're going to use the similarity approach to justify that result there. Okay, is equal to the angle of sector over the revolution of the circle. So, white and tidy writing, it's been a few days. Okay, so we're getting a similarity, so we're relating area with angular measure in radian. Okay, so the area of sector, so I'm going to call that capital A because that's what we're justifying. Over the area of the circle. So how do I find the area of the circle again? By r squared. Equal the angle of the sector. So it is theta. Made an angle theta in the centre. And what is the revolution of the circle? 2 pi. So you also need to be in radian mode. Okay, so area, so we bring it up. You get pi r squared theta over 2 theta. Sorry, 2 pi. There is a half r squared theta as required. That's how they develop the formula. Okay, examples. We need to find the area of a sector of a circle with radius 10 centimetres and the angle is 4.3 radians. Okay, so we can approximate the radian measure in a decimal or fraction. Okay, it doesn't always have to be in terms of pi. Alright, or it can be exactly 4.3. Okay, so a radius, circle of radius 1 that has an arc length of 4.3 makes an angle of 4.3 at the centre. Okay, that's the definition of the radian. Alright, so just a straight application of the formula. So half times 10 squared times 4.3. So 50 times 4.3.
260.
Okay, so 50 times 4 is 200, and then 0.3 of 50 is another 60. Yep. Area, so we had centimetres squared. Okay, because you're given the radius of centimetres, the area will be centimetres squared. But any questions? Nice and simple. Right, so B. The length of the arc, AB on a circle with centre O and radius 10 centimetres, is 8 centimetres. So, length of the arc is 8 centimetres. The radius is 10 centimetres. Find the angle AOB in both radians and degree. So we need to find angle AOB, radians and degree, and then calculate the area of sector. Right. So the question telling you what you need to do first is you find angle AOB. Okay, so you have diagrams always helpful. Okay, so you've got radius of 10 centimetres. Okay, it doesn't have to be accurate, just enough to understand what's going on. Alright, so the radius is 10. And then the arc length for that length there is 8 centimetres. You need to find the angle made at the centre, angle AOB, that's the arc AB. Okay. So we find the formula, the length is r times theta. Okay, so therefore theta is going to be the length over the radius. Okay, it's the formula for arc length of the circle, radius r, angle in radian. So it's going to be 8 over 10. The angle is going to be 4 over 5 radians. Okay, so now we need to find the area of that sector. So now that we have the angle made at the centre, we know the radius, we can now find the area. So 4/5 of 50. Right, so that is the area of the sector. Any questions on that?